Hi, I'm Jimmy Chang, and we're here to talk about chi-square probabilities. Now, chi-square probabilities is a very important part of statistics because oftentimes you have to use different scenarios, and along with those different scenarios, you have to think about what kind of probability distributions to use in those various scenarios. And some situations will fit certain scenarios and therefore those certain probabilities, and chi-squares are one of them. Now, in chi-square probabilities, we're talking about a sum of a certain number of squares of, we'll use k, independent standard normal random variables. So k, that's what k stands for, and we're talking about the distribution involving the sum of k standard independent normal random variables. So let's talk about the formula real quick. So you have f of x semicolon k, which is equal to x to the k over 2 minus 1 times e to the negative x over 2 over 2 to the k over 2 times gamma of k over 2. Now, the chi-square distribution is actually a special case of the gamma distribution. So by now, if you're watching this and you're taking statistics, you should probably already know what the gamma distribution happens to be. And needless to say, k is pretty prevalent throughout this particular formula. Now, this is of course if x is greater than or equal to 0. Now, the probability distribution function is going to be 0 otherwise. Now, like I said before, k is the number of independent standard normal random variables, and the chi-square distribution is the sum of the squares of that, but k also stands for the degrees of freedom. So, needless to say, the chi-square distribution does incorporate the independent normal random variables, and depending on the scenario that you would use the chi-square distributions as a result. So, I'm Jimmy Chang, and that's a brief discussion of the chi-square probabilities.